Hello everyone, how's it going? Okay, I'm gonna get the music going real quick before we get started. Question for you, Wei. You didn't miss anything. Well, missed a bit. We just went over some basic interview techniques and stuff like that. Um, but Wasn't so much basic interview. We did some what do we call it? Time complexity problems, and we just did a few problems here and there. Went over a few examples and behavioral interview examples. Let me know if the music is too loud. I can lower it a bit more. But outside of that, we're going to kick off this session. I just go over. So real quick, hey, I'm Kev. So I'm a coach at Major League Hacking. I use the he, him, his pronouns. I do a lot of different things. So feel free to talk about anything really. So schedule overview for tonight. We're just really going to be doing a lot of coding time. And that should take up most of our time tonight. Yes, for sure. I just like a tad bit of background music. I just lowered it a bit more. Okay, cool. So yeah, from earlier, we did part 1, which was on Sunday, which we broke down a technical interview. For part 2, we did a technical showcase, and we did some example. We went over what the type of interview technique. We also went over what type of IDE are generally used, and these coding challenges. We went over some examples, and we did some prep. So right now, we're actually going to be doing a full coding challenge live. I don't know if I'm actually ready for this because I have not done one of these in a while. Pretty rough on my coding, but that's okay. The point is we learn. So when you do these for practice, it's a great learning experience. So always feel free to actually use your resources and learn. So coding time. Let's bring up. Okay, so that was the test code from HackerRank. This is what we did earlier this afternoon. We're going to skip that. We're actually going to go to CodeSignal. CodeSignal is great. It provides you one practice exam every 24 hours. And this is actually modeled off of a real coding assessment. That's great. If you haven't checked in, make sure to check in. But yeah, so it actually makes an amazing resource. You can do 4 questions. They generally scale around the same difficulty of what it would be if you were to do it. So pick your language. How it generally works is you get to the coding assessment. So it's 1 hour and 10 minutes long. You complete 4 questions to make sure question was finished. Solve question in any order. There's some agreed things. I will not reproduce, copy, or publish certain information I come across during my session, including them to This is all the pledge you normally have to do for a real exam. They mock it here for the coding practice as well. So we're gonna go ahead and hit start. So let's go. So they're all single function. So it's a timed exam. So we have 1 hour and 10 minutes. It's going to load. First, we're going to read the question. This might be a bit quieter today because we're just going to be taking this. So I'm actually going to up the music a tad bit. So make sure you read the question. I like to drawing this out. I can probably read the question. So you're given an array of integers and 2 numbers, left and right. You're tasked to calculate a Boolean array result where the result I is equal to true if there exists an integer x, such that the numbers I equal, so the number that index is equal to I plus 1 times x, and left, and it's less than left. It's greater than left and less than right. Otherwise, it should be false. So 4 numbers. So make sure you read your full example when you do something like this. So 4 numbers, 8, 5, 6, 16, 5. Left is equal to 1 and right is equal to 3. The output should be solutions, numbers, left, right is equal to false, false, true, false, true. 4 numbers, 0, 8. We need to find x value such that. Okay, so we need to compute a x. We need to find a value x such that rules function. Actually, I don't know if I can do this live, so give me like 1 second. I want to make sure. Here, we're actually gonna do something else. I'm not sure if I can do that live. Let me check. If I can, it's okay. We'll do some other questions. Like 1 second. Yeah, I don't think I can do that one live. That's okay. I'm gonna be careful about that. It's okay because we can always do Code Arcade. So let's do. So all these resources generally also have things you can do. So for example, here's all the challenges you can do. There's Code Arcade for things to do. So like there's a lot of entry level questions like you could add, and you can continue to build upon skills. There's also, let me pull this off real quick. Interview practice. Let's see. Maybe we'll just do some LeetCode. LeetCode. This might not go well because I'm doing LeetCode live. I guess this is also good. You can follow along. Let's see. Give me 1 second. I'm gonna sign into my LeetCode. Oop. Oop. Okay, I think we're fine now. Cool. So here's the LeetCode. Let's see. So here's the acceptance rate for things. This is a new LeetCode account. So we're gonna start here. I guess since I think I started this, maybe it's a medium problem. Let's start with an actually easy problem for now. Then we'll go harder. So let's start by difficulty. So let's do an easy problem real quick. So easy problem, and then we'll scale up by difficulty. So I think I've done some of these. Let's pick one that's pretty simple. Is there a randomizer? Pick one. So I didn't pick. So let's see. So we're gonna do special positions in a binary matrix next. Okay, cool. So we're gonna do this in Python 3. Cool. Okay, so our job is to, given MXY binary matrix, return the number of special positions in the matrix. A position ij is called special if is equal to 1, and all other elements in I row are 0. Row and column are both. Okay. So that means we're given a matrix. So we need to, so this is a case, so this one doesn't work because there's a 1 here. This one does work because both the column and rows are null. And is it always a 3x3? No, it's m times n matrix, so it could be different. And then you go to matrix length, and then you go to matrix length. Yeah, so they can technically be different. Okay, cool. So we need to keep that in mind as we're developing the solution, is that they don't have to be of the same length. They show us 3x3s, but they can be anything. So first things first, let's write some pseudocode, right? So first I want to find, can I make this bigger? I don't think I can make this bigger, can I? Oh, I can. Okay, cool. So first we're gonna find the length of the matrix. We're also gonna find the length of each row in the matrix. So basically the column length. So let's do that real quick. So we're gonna do it's list of list ints. So what do they call it? I think it's matrix is gonna be dot. Is there? I think there's no autocomplete. Oops. Nope. That's one. I can't recall if this just. I don't think it can come with autocomplete. Oh, it does not because of the premium feature. That's fine. So, matrix. So we're gonna do row is equal to row matrix, not length. It doesn't come with all of. Give me 1 second. I'm gonna see if I can pull up something that does have autocomplete. Generally do assessment that do come with autocomplete unless you're required to do it by hand, and they don't. Let's see. Give me 1 second. Okay, let's clear this out. Take this back out. For the day, don't need. We're gonna pull back up the problem. Grab what we have. Just throw that. Okay, cool. So we're first gonna make a variable, a row, and row is gonna equal the matrix. Not. Oh, I forgot. There's no length. This is exactly why I need autocomplete, because I code in so many different languages, I forget what can do what. And then we need to do column. So column is going to be equal to the length of a matrix. Let me just put 0. So that way we're going to get both column and row. And let's go back. Actually, can I do that? Yeah. So the problem here states, let's see. So once we get both the column and row, we need to essentially given wait. What's the thing? I think they're lowercase, yeah. Okay, so list. Now we have both the column and row. We need to check if it's special, if it's equal to 1 and all others. So now we just want to go through. So for, let's say, I in range, for I in range of the length. So for speed's sake, okay, let's write some, let's write some pseudocode to it. So loop through and check if each item in the matrix. Oops, I totally forgot. Let's see. To the website. So this website is LeetCode. This is LeetCode problem. Let me see. This is LeetCode problem binary matrix. I haven't done these in a while. I forget things. That's okay. So loop through each item in the matrix and check if they are 1. If they are 1, check within bound to see if the rows and columns around it is so we're gonna need to do a few checks actually. We need to check so everything to the left, everything to the right, everything to the bottom, everything above it. So if they are 1, within bound to see if row and call around it is all 0. If not 1, move on to the next item. So we know, so if I get to, let's say, this 1 here, let's actually example 2. So if I get to 1 here, this is it, that's it. So if I get into the center 1, I need to move. I can't. This 3x3s are not a great example because 3x3 only would cover like cases where you just check one to the left, one to the right. So like for example, this one, I need to check 2 to the left, 1 up, 1 bottom. So I can't just check around this one. I will have to check everything in this row to make sure it is the only one. Okay, actually that's not hard because essentially what you need to do is just if you find a 1, it's just check if that whole row and that whole column only has that 1. Which is perfectly fine to do. So I'm not going to do this efficiently, especially because I'm coding live. I probably will not be able to think efficiently, but let's start by going through the matrix and go through each item. So let's do while. Let's see. If we do a while loop, we just need to go for while. Okay, so there's a few ways to make this efficient, right? So we can check just each row and see if there's multiple ones. If there's multiple ones are automatically eliminated. That's one way we can do it, right? We can just go through because each row is set up like this. So we can just check this row. If there's multiple ones, there's already no point of checking the rest. So that row would be eliminated by default. So we can first go through check each row, and then if you find one in a row, you can then check if it fits in a column. Okay, so let's do that. So for while, let's actually do for I in actually no for let's do. So that will give me what? So that will give me the row it's in, and then I need to go through the row and figure out. Wait, it will give me the row. If I do it in that method, I would get each row. So for example, row 1. And then I need to figure out if I get this row is good, I need to check to then go through this row. So let's do that. Okay, cool. So for 1 in row, or for row in rows, if 1 in row why is I call it row. So let's change. Oh, okay. So let's update our naming scheme. So it should be num. If you have if you want to toss any suggestions in chat, feel free to. For row and row, I'm not really good at coding under pressure, so this is great. So watch it would just be matrix. For if 1 in row. Okay, so we need to check if there's multiple ones in row, so we can there is a function for this. I can't recall, let me see. So Python function that goes that maps list to. I can do it by hand too, but it takes more work. Okay, let's go for non-efficient, but this is going to be really non-efficient. We can solve it. So for row and mat, for number and row, and then we just do temp counter. It's so non-efficient, but that's whatever. I'm really bad at coding under pressure. It's okay. If for 1, if number is equal to 1, counter plus. Oh, actually, this is not C++. Plus equal 1. If temp counter is equal to 1, we will then do list of row with 1. Oh, I hate coding live. Then we do list of row is equal to 1. Append. Then we'll append row. Well, we actually want the index of row, so we're gonna do for switching this up arrow for I and for I in range of the length matrix for number and matrix of I. If number is equal to 1, we increase the temp counter for 1. We're going to bring this temp counter actually down, so it actually resets each time. Make sure you do that. So that way, temp counter, and then if temp counter is equal to 1, we will do list append not row, append I. So this should go through. So I'm gonna first do main if name is equal to main, and then we will do, how do they do it? So they do inputs like that. Okay, so I'm just going to do copy this one real quick. Copy that, bring this over, and then we're gonna do print number. Okay, we're actually, I'm gonna get out of the class. There's no need for it to be in class. I'll highlight everything, tab it out one more. So num special, and then we don't need self because this is not a class, or we can adjust this once we put it back and to make it run easier locally. We're gonna do this, and we're gonna put in the matrix. Reformat file. Okay, cool. So now let's do, we're gonna in here, we're gonna do return. It's not what we're gonna return at the end of the day. So I'm just gonna take out this return here too. Let's work. So we're gonna temporary return list of rows of only 1. So this should return all 3 of them, because all 3 of them meet the list of row of only 1. So it turns 1, 2, 3. But if we do, actually, I just saw that for no apparent reason. Let's see. So is there a test case for a row? Ooh, that is smart. So there's actually never a test case for this. So we cover a coverage that they didn't have, but that's good to have in here. So now we know that. So when we have rows, so now we need to check the column for each row of that only has 1, but at the 1 position. So I'm gonna go through again. I'm gonna do for I in range of length. Okay, no, we're just gonna go for I and range of length of list of rows with only 1, right? So we're not gonna go through the whole list again. And then now I'm gonna do for I and range of length of list of row with 5. We're gonna now do we want to check find. So I'm gonna check up some Python command. I think Python methods on methods. So we're gonna do, here's the method. So returns the first index, the first element, count, insert, pop, remove, previous. It adds an element to a list. Variable, remove to the list. Wait. Do I not remember? Is this not a real thing? And copy, count, extend, index. Okay. So then we're gonna use list row of 1, and then we're gonna do I dot index. Oops. List of 1 of I. Oops, I don't. No, yeah, that's right. So actually, no, that's not right. Before I, that is dumb. I wrote this actually, because we know this value doesn't change. So we do this, and then we will do matrix of I index of 1. So where the one, location loc of 1 is equal to that. 1. And starts computer. So we're gonna get the location of the 1, and then now we need to write the logic to go check all columns. So let's make first a temp. Actually, no. Yeah. So it's gonna be temp counter again. Equal to 0. Oh, I'm really bad at these. Okay, cool. So we're gonna do for I in list of row counter. So we're gonna do for J, and so now we only want to move. So how index these were, right? So this is technically 0, 0, 1, 1. I mean 0, 0. I mean what? This is 0, 0. This is technically 1, 1. 0, 0. 0, 0, 0, 1. So this is 0, 0. Then it's 1, 0, then it's 2, 0. So the second index stays the same, the first moves. So for J, and so we're moving the number of rows or number of columns. Let's think. So we just checked the columns actually. So we're moving, so actually in list with, so these are actually columns, so that's okay. That's not how this gets a bit confusing. So we're just gonna leave it called row. So list of rows of 1s. So we're actually going to go through, this is 0, 0, this is 0, 1, 0, 2, 0, 0, 1, 1, 0, 0, 0, 1, 0, 2. This is 0, 1, 0, 0, 0, 0, 1, 0, 2. This is 0, 0, 1, 0, 2, 0. So for I and, so we actually need a number of rows. So in, or in range of length. Alright, I'm pretty rusty at this. I've not done this in a while. For J in range of length of matrix. And so now we will go and do, we don't even have to start at location. We can just go from top to bottom. So we will do if matrix of J, the moving one, and the actual location of 1. So because that will actually give me, let's say if it's here, here, or here. That's good. And then it's equal to 1. We will do temp counter plus equals 1. This is really not efficient, but that's okay. We're practicing. You can pause and go back and see how to make this more efficient, right? Then if we do if number, or if I do if temp counter is greater than 1, then we want to put into that. Oh, actually, we're also going to build out the final matrix, right? So I need to do that. I should have kept that in mind. So let's build, because you need to return. See, this is why I say you have to really read the problem. I did not read the problem like that. So I need to return a matrix of yes or no, right? Position example. So given a MX matrix, return the number. Oh, just the number. So return the number of special positions. Okay, so then we will just do for I, and that counter is equal. So that's okay. So we don't need to keep track of that. If it's equal to 1, we will then do number of special. I can't spell number of S. I'm just going to S row. S row is equal to 0. If the temp counter is equal to 1, then we will just do num S row plus equals 1, and then at the end we will just return. This is still not efficient, but that's okay. Return. This is just how you would generally go about practicing, right? So we're gonna do that. I'm gonna put this above code. Remove that space. Remove all this extra space. Then if we run this now, run. So I got 1, which is correct. Let's see. So they have a few test cases right here. So actually, let's run it with this one, right? So this one I should get 3. Copy this. Bring it back. And then we're just going to go here. We're going to do print. Special. And we're going to run it. I should get 3. Okay, cool. So this code works. It's not gonna lie, 100% not efficient. I just haven't done this in a while, so it's pretty hard. But yeah, so then we're just gonna move this back in here. We're gonna shouldn't have to change anything because I didn't use anything that wasn't named. Then I can first run it, right? So it's gonna run against the 2 test cases that it gives and tells me how it actually does. Oh, runtime error. So indentation. Okay, that's great. Oh, I guess it's because when I wrote in other thing, give it 1 less indent. So we're just gonna have to highlight. Oops. Gonna highlight everything and tab by 1. That should fix the indentation error. Comment that out by 1, hit run. So we accepted both case 1, case 2. It took 47 seconds. Honestly, not great. Then we submit. This will run against all the hidden cases too. You can definitely add a way better performance than I did. You can see it tells you. So I beat 40% of performances. Some people I beat 20% use of memory. So I didn't have a great memory use, and performance-wise, it was pretty poor. But that's okay. But yeah, that's perfectly fine. Is there any questions about anyone? But you can. What's really great about LeetCode is, right, if you don't understand, you can always go to solution, and they tell you multiple solutions, right? So like, this is a way to do it. Not how I did it. This is a way to do it. There's multiple ways. This guy did it in so many different ways. This is how you would learn, right? So you would code one of these up, see where you stand, where you fit, and then try to do better. You can learn from this. You can do it all sorts of languages. I can code this in a different language if I want. So that's an easy problem. It was not easy for me. I just have not done these in a while. But that was not great. Let's see. We're gonna reset and let's try to find a harder problem. Wait. Why is that gone? I go to problem list. Okay, cool. So let's pick another problem and let's set the difficulty to medium this time. And then we're gonna do pick one. Okay, so longest palindromic subsequence. Given a string S, find the longest palindromic subsequence length in S. A subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. So, for example, the input. I'll drop this in the chat. Actually, I'm going to read this real quick and see if we want to do this. Input S is equal to this. Output one possible longest palindromic sequence is BBBB. Just one away. Given a substring, find the longest subsequence length in S. A subsequence is a sequence that can be derived from another sequence by deleting some or no element without changing the order of the remaining element. Ooh, this sounds pretty bad. I don't like strings, so we're gonna hit the refresh button. Not a fan favorite. So we're gonna go back to here. Another one. I also don't like doing palindrome problem. Given an integer array of nums, return the number of the longest increasing subsequence. Let's do that. Okay, cool. So we do this problem. So I'm gonna minimize my screen again, take the subsequence, post it in chat for anyone who's interested. Yeah, I need to actually do practice coding more. Doing this live has really made me realize that. Okay, cool. So we're gonna first take this function again, then we're gonna bring back up list. Then we will just move these calls. I'm gonna work right underneath here. So we're gonna start here. So here's the thing. We're gonna delete what needs to return. Okay, so I want to return for test. I don't know why they use capital list. It's lowercase. I'm going to take out self because we're not working on class. We're going to functionalize this. Okay, cool. So let's read this. Given an array of nums, return the number of longest increasing subsequence. What does that mean? Return a number of longest increasing. I noticed the substring has to turn into a page. So if we have 1, 3, 5, 4, 7, the two longest increasing subsequences are. Wait. 1, 3, 4, 7, or 1, 3, 5, 7. What does that mean? Return the number of longest subsequence. As in, why couldn't this be 1, 4, 7? Let's reading. So if it's all 2, it's 5. The longest longest increasing subsequence is 1, and there are 5 increasing of length of 1. Wait. This is what I mean, like you want to really understand the problem first. I currently don't understand this problem, which is fine. Let's go back. So it says, given an array of integers, okay, so I'm given this. My job is to return the number of longest increasing subsequence. I get the longest. I don't get the increasing subsequence. So that the sequence has only strictly increasing. So if we have 1, 3, 5, 4, 7, because there's a drop off here. Then why do we include 7? Wait. So 1, 3, 5, 7, or 1, 3, 4, 7. Okay, that's the two longest subsequence. For 2s, it would be what? So 2, so it has to be strictly increasing is why. Okay, so let's see. So our test case 1 and 2 are the one they gave. Let's think. So at least from my understanding, I think what it means. My thing is, what if it's longer, right? So it's 1, 3, 5. Let's say there's 4, 6. So would it be 1, 3, 5, 6, 7? 1, 3, 5. Longer number of longest increasing subsequence. Oh, let's read this explanation. The length of the longest increasing subsequence is 1. So it's from 2 to that, and there are 5 increasing subsequence of length of 1. Because it has to do with the length without dropping. So it's 1, but this would be 1, 2. Well, that's 1, 2. And the 2 longest subsequence. Wait, this would be increasing once, twice before it drops. So how did the 7 get in there? It's okay if you don't know. So if you ever don't know, you can always check discussion roles, see if anyone has said anything. See, there's only 2 longest subsequence, but the expected 3. How come is that? Don't know, you can always check solutions. So this might be one that I currently really don't understand the problem. I might read the solution, look at some possible solution first. So I'm interested in a solution in Java. So I'm gonna see. In Python. Dynamic programming solution. So they use dynamic programming. Let's see what they did. So first, if not nums, return 0, and it's equal to the length of nums. Sorry, I had to play some more music. N is equal to the length of nums. Length is equal to 1 times n. Count is equal to 1. Well, this just expands this. Okay, so that does that. For I in range of 1 to n, for j in range of I, if the num of I is greater than the num of j, length is equal to the maximum length of j plus 1 and length of I. So we need to compute count also. So if length of I is equal to the length of j, length of I is equal to the length of j plus 1. Count. With detailed explanation, let's see what they say. Okay. If not, nums return 0. Okay, yeah. We're gonna try a different problem. I don't know. I can't do that problem. I still don't fully understand what the problem is asking me. That's fine though. We're gonna go to medium. Let's randomly pick another one. The medium category. So there are n persons on a social media website. You're given an inner array ages, where age of 1 is the age of the ith person. A person X will not send a friend request to a person Y if X does not equal Y. If any of those following condition is true. Okay. So X can't be Y. And then, so if the age of Y is less than 1.5 the age of X plus 7, or if age of Y is greater than the age of X, or if the age of Y is greater than the 100 and age of X is less than 100. Otherwise, X will send a friend request to Y. So, okay. Note that if X sends a friend request to Y, Y will not necessarily send a friend request to X. Also, a person will not send a friend request to themselves. Okay. That's great. This is a pretty problem too. The age is equal to 16 and 16. So we just need to return the total number of friend requests made. Okay. So this would need to start at each location, go to the beginning, go to the end. So we will loop for each one, and then we'll go through the whole thing when it's not equal to itself. We're going to do this inefficiently. Like always, we're going to first just copy this function code. And actually here, I think I have something in mind for this one. So we're going to walk through this one too. So I don't know why I did this. List is lowercase. Cool. So first things first. So we'll go through each one. Then 16, 18, 16. So there's only 2 because 16, they have to meet if any of the following condition is true. So we'll just go through each of the conditions to see if any of them is true. If it is, it'll send a friend request. If not, I won't send a friend request. And friend request can be one way. It does not do both ways. So this one does make sense. So we always want to read your constraint. Those are pretty important. So n is equal to the age is dot length. What? N is equal to age is dot length. What is n? What did we mention? Oh, then number of person. Okay, cool. And then 1 is less than or equal to. Okay, cool. So this is essentially how efficient your code needs to be. It gives you a kind of constraint on how big of a thing they'll give us. I might fail the efficiency thing here. That's okay. So because I'm probably gonna the solution I can think of, which we'll actually code out together, is not efficient at all. But the first thing is remember even on assessments, you want to at least complete the problem if it's not efficient. And then move on to the next problem. So first is loop through. Okay, let's get the length of the list, and we're gonna loop through. Oops. Loop through. Why is this tossing me an error? And then expected. Gotta indent. Because main has nothing. Pass. Why are you yelling at me? I have no clue, but that's okay. We'll worry about it later. Loop through the list for the age you are comparing. Then you would just loop through the list again to compare to all the ages in the list. So this would technically be this. So first things first, let's get the length of this age. So let's do, length of list. So list. No errors like that. Thanks. Okay, why is it telling me that? Wait, what? Why is it doing that? that was odd. Okay, so first, so we're gonna get length of list is equal to len of pages. So we do that, and then we will go through for I in range of the len of list. Then we're gonna do another for loop for j in range of, but we still want to go through. So this is super inefficient, but that's okay for now. I'm putting live, not my brain. We might go back and so loop through the list again to compare. So this is what the second loop is for. Move this comment up. That. Okay, so that's what that's for. So the second loop we would do, if first thing is we want to check if I is equal, so only if I does not equal to j, so we're not the same location in the list, we will then do the next thing, which is check the conditions, right? So first is, so to determine if we send a friend request, we will just do if, let's write all these conditions out first. So let's write out condition 1, boop, condition 2, boop, 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 condition 3. This is not efficient, but don't mind it. These things. So first thing is write that condition, right? So if age at x, let's do, so let's call this x and y. I think this will help us with the actual thing. So first is make sure x does not equal to y. X is the person we're checking, y is the person we're checking against. So we're going to check everything for x. So if age of x, what am I doing? If age of y, I might even just is less than equal to 0.5 times age of x plus 7. Why is it yelling at me? Because it's ages. Okay, got it. Then we will, they basically just wrote the condition for us already. Then we would just, so we need to also create a thing to keep track. Keep track of number of friendship, of our friend requests. So we're gonna do friends is equal to 0. So sad, no friends. Then we will come down here and then we will do of friends plus 1. Then we're gonna write out condition 2. Same thing, right? So we'll do else if. So else if age, I think I can essentially just come here and copy these conditions over. And I'm just gonna add in the s. Or computer science, we take shortcuts. This one over, essentially written for me already. We're gonna do another else. Add in there, and we'll do that. We'll just add in the s's. We're gonna close that out. We're just gonna do, so if any of these are met, we will do this. Actually, another probably more efficient way of writing this would have just been write the opposite and then write an else to the add statement. We're gonna change this to and. So alright, so yeah, just ignore the constants for now. So we just kind of put in our arguments. So this should count the number of friends. We'll just order the whole thing. Yeah, we can just do that. That is 100% true. That is a true comment. Brain's not fully functioning, coding live, so don't mind me. You're gonna get what you get. Because I'm also trying to talk, not think about this, and explain. It's a lot. Okay, so we're gonna first try this. So it should go through, check each thing, return. I don't honestly at this point. My brain's not functional. I don't know if this works, but we'll see. Return num of friends, and then we can do print. Then let's do print num of friends request ages. Let's do 16 and 16. And then we'll see how this goes. 4. 0. Okay, so something is wrong. What is wrong? Let me think. We checked that, which is correct. Wait, why is that 0? Let's see. I should probably realize this, but it's okay. Let's just see what's going on. I'm pretty sure it's just probably failing this check. Wait. If age of y is less than to the age of x plus 7. Wait. So if age of y, so 16, is 16 less than or equal to half of 16 times age plus, this is give you 2, right? Yeah, it's give you 2. So that condition isn't met. Is 16 greater than that? Which that can't be true. Is 16? Let's see here. If this is that. Oh, this is do not send a friend request. I am actually so trolling. This is why you have to read the problem. I meant to flip this. So actually, this can just be changed to this. And then we just add one more else. Then we put in what we had there. Oh. Okay, now this should work. Let me take that off for a second. Give me 1 second. Let me just check something. Very cool. Cool. So that worked. So it should work for all the cases. We're going to take this and put this back in. I'm going to tab it 1 first. I'm going to put this back in here. So we're going to hit enter, put that in there. That should everything tabbed right too. And then we're going to now run. It's definitely not optimal, but this is definitely a working solution. As for case 1, case 3, 53, 58 milliseconds, it's pretty bad. And we'll just run it through all of it. But yeah, again, if you're actually doing this as time limit exceeded. So you see, I knew this was gonna happen. It's because how inefficient this is. So let's try to see if we can make it more efficient, right? So this is during like an actual assessment. I would say put out your thing that can give you the fastest time. If you have extra time, come back and make it more efficient, right? So if the list is too big, I should not want to go through this multiple times, right? So there's other ways of do this. Let me think. To cut down on how this is done, there's one way you can do is probably map all the ages to. You can do this by map, right? So I think if I'm not wrong, I should be able to loop through once, put all the ages into a dictionary, then just loop through the dictionary once. So instead of repeating ages of multiple things, and then just multiply it by the number of items in that dictionary. So if the key is 16, there's two 16-year-olds. We know they'll send it to each other, and then you would just multiply it by the number amount each. I'm not gonna do that for right now, but that is another possible solution that's faster. I can't recall the details. I have to look at some more Python things to actually translate the list into a dictionary. So it's like I have to map it over. So after I map it over, I should be able to compute, go through and actually compare the keys, and then based off the number of keys, you multiply that by the number of friends you add, and I think that gets you the correct answer. If can always check, right? So estimated solution that technically didn't work for audit, just test cases. This is the public one. So like this is way big. And that failed. You can always go to solutions and see Python easy solution using binary search. Use binary search. So first you do def, if not age, if not ages, return 0. That didn't. Okay, that's fine. And the count is equal to 0, and it's equal to length of ages. Okay, age is not sort, so you sorted it first. Then you did for I in range of n. A is equal to ages to the I. If A is less than or equal to 14, you continue. Okay. Then it goes IDX1 is equal to binary search. Binary search ages. So you can use libraries generally in these assessments. I am not sure of the solution. I have to look at it more in depth. But yeah, okay, cool. That's like a medium problem. I actually think it takes me a lot longer to do a hard problem in practice. So we can take a look at one. Oh, it's not a fully successful medium problem, but that's okay. Let's do a hard problem. Oh, actually, no, I'm not doing this hard problem. Maybe I lied. Maybe we won't do a hard problem. I'll show you. Let's go back to our slides. Any questions? Let's do that for now. I just don't know if I feel up to any more coding. If you have any actual coding assessment that you want to go over, we can. I can generally, so I'm being completely truthful and honest, I can generally do easy problems pretty well and do medium problems. I can do 1 or 2 hard problems. It just takes a lot more time and effort. And some of the thing gets really fancy. And I just want to remind everyone that everyone's at different levels of computer science or coding. So don't feel bad if you can't do all the hard problems or do the easy problem, do the medium problem. Because remember, coding assessment exists for all stages. Generally, of the process, it generally exists, I think, less when you should get older with bouts of experience. But coding interviews are less just tailored towards entry level. And then if you are entry level, don't be upset. You really, rarely see a hard problem. You generally see your easy to medium problems, and generally it's like 2 to 3 easy, 1 medium, or 2 medium. So if you have 4 questions, what I've seen is you get like 2 easy, 2 medium questions. But yeah, is there any questions I can answer? If not, this might be it for our technical interview prep part 3. And it will conclude our technical interview track for Global Hack Week, December 2023. Yeah, I think I'm gonna work on a cyber track for next time. Technical interview kind of stressing me out a bit, but that's okay. Just know that everyone's in the same place, and that everyone is learning. So as long as you keep that in mind, you'll do great. And it's pretty fun. Let's see. No questions in chat. If there's no questions in chat, let's see what is our upcoming stream after me is going to be. So we're going to have our machine learning track part 4 with Will at 10 p.m. He's going to go over machine learning things. It is currently 9 p.m. So in an hour, we're going to do that. I will stick around for a bit for any questions and just hang out. Maybe we'll play some Tetris or something, or maybe I'll do another coding problem. I just don't know how I really feel about that. And then if you have not yet, make sure to check in for organize.mlh.io participants events. I should just post that link in the chat. And then make sure you go there to check in. Boop. Checking in is great. Here is the check-in link. If you have not checked in, I wish you guys rest of your nights, and make sure to come out for Will's Machine Learning Track Part 4 at 10 p.m. EST. Have a good night, everyone. If you have any questions, feel free to at me. Yeah. Have a good night.